Hey guys, today we're looking at 5.1, which is all about nth roots and rational exponents. So we're going to start by just taking a look at what an nth root is, and working kind of on some definitions and some patterns that we have with them, and then get into actually applying them. Now we've done roots before, primarily square roots, and then we've messed around a little bit with some cube roots back in the beginning of this school year, but we've been doing square roots for years, right? We've been doing squaring and square rooting things for quite a while now. Now, more generically, an nth root, we have the top one here is our definition, an integer for an integer n. So if we have some exponent n that is bigger than 1, if we have b to the nth power equaling a, which means b is my base, n is my exponent, equal to a, then we can say that b, that base, is the nth root of a. Another way of writing this is putting it in radical form. So this is what we call exponential form. This is what we call radical form. It's the same information, it's just rewritten in two different forms. So here, if we knew, we'll do a little example in exponential form. Let's say 3 to the second power equals 9. We know that that equation is true. My base is 3, my n power, my exponent is 2, my answer that's equal to is 9. Which, if we rearrange that equation, we would get that the nth root of a equals b. So the second root of 9 equals 3. Which again, makes sense. Those two things are equivalent to each other. We know that both of those things are true. This is just what nth roots are. Now, obviously, we're going to get into more complex ones. We'll get into some that are much larger than just a second root or a third root, cube root. We'll get into some much higher evaluations of those. We'll also get into today rational exponents, therefore kind of working backwards to figure out how those things work. I'm going to go ahead and leave this blank, or we're going to go ahead and leave this part blank for right now. We're going to fill this in with some different information. Let's take a look and explore our different options for our n's and my a values and how those two things affect each other. So we're going to look at what happens when my nth root, my root is even and odd, and then my number that is equivalent to is bigger than 0, smaller than 0, or equal to 0. So let's start with the easy one. N is even, which that is going to be, we're going to take kind of our mindset is going to be looking at square roots. So what are some things that we know about square roots, how many solutions we can have, that kind of stuff. So if we're taking the square root of something, and that something that we're taking the square root of is smaller than 0, so let's just say we're taking the square root of -3. How many solutions do we know are possible there? Well, we know that we have to deal with imaginaries. In this case, since we're dealing with roots right now, we want to just deal with real solutions. So if I have an even root, I know that if I'm dealing with even roots, not just square roots, that if I have an a value, a number inside that radical, that is less than 0, then there are no real solutions. Right? There's no number multiplied by itself that's going to make a negative number. Moving on down, if I have an a value that is exactly 0, meaning I have, again, we're going to use square root as our example. The square root of 0 is 0, therefore our answer is 0. So we have one real solution. And in this case, I'll put in parentheses, my answer is 0. And that's always going to be the case. Now, if my a value is bigger than 0, so let's say we have the square root of +3 now, that looks a little bit different because in all of our cases, we're going to have two solutions because we know anytime we took a square root in our equations, we had plus or minus, positive or negative solutions, right? If I had the square root of 4 instead of 3 here, I'd end up with plus or minus 2 as my solution, or as my solutions. Here, square root of 3 is not a nice number. It's irrational, but it is still a real solution. whatever that number is, 1.7 something, that still is, well, there's one positive and one negative of that to give me the square root of 3 after I take my square root. So here I end up with 2 real solutions, and those solutions are just plus or minus whatever the nth root of a is. So you'll have to be able to figure those out, and we'll work on that in a little bit, but at least those are our options. Now, the odd side is a little bit different because this is one we don't have as much experience in. If we're trying to do, let's just say, the third root, which is the easiest one to kind of wrap our heads around, the cube root means we're looking for some number multiplied together 3 times to give me what's underneath that radical. So underneath that cube root symbol. So if I'm taking the cube root of something that is negative, such as, let's say, the cube root, the cube root of -8. I'm trying to figure out what times itself 3 times is -8. In this case, we should come to the conclusion that -2 is that number. -2 times -2 times -2 would give me a -8. But notice here, I don't have plus or minus as an option. I can get an answer for a negative underneath my radical when it's a cube root, or really any odd root, but I only get one solution. And in this case, it is, I'm going to do a little squiggly. It's always going to be negative whatever the nth root of a is. And that's, again, look, my a value, doesn't matter if it's positive or negative, it's negative of whatever that is. So, like, again, if this was -8, I would be looking at negative whatever the cube root of +8 is. Because sometimes for many of us, it might be easier for us to kind of put that mindset to it, where it's easier to figure out what times itself 3 times is 8, rather than what times itself 3 times is -8. But again, it's always going to be negative for my solution. There's always going to be exactly one of them, and it's whatever number multiplies n times into whatever my a value is. For a equals 0, that is still the same, because it doesn't matter if we have 3 zeros being multiplied together or 2 zeros being multiplied together. My answer is still 0, so the third root of 0 is 0. So we have, again, one solution, and that answer is always just going to be 0. No big deal. When my number is bigger than 0, so I have a positive number, that's the cube root of a positive number is one solution, and it's whatever the nth root of a is. But here, it can't be negative, right? If I'm looking again at, let's just say I'm looking at the cube root of 8, positive 8, I can't multiply 3 -2's together. That would give me an 8, but it would give me a -8. So I can't use the negatives when I'm dealing with a positive underneath my radical. So that's kind of the nice thing here about odd exponent or odd roots, is no matter what, you're always going to have exactly one solution, and the sign underneath that radical should be the same sign as your answer. So if I'm taking the cube root or an odd root of a negative number, you'll get exactly one negative number for your solution. If I have the cube root of a positive number, you'll get exactly one positive number for your solution. So that is our roots. That's how we handle our different roots. So part of our problems, some of the things that we'll have, are asking us to just evaluate given roots, given a values, given n a values. So looking over here in box 2, they're asking us to find the indicated nth root of a. And here, this is one way they could phrase the problem. It could just say, hey, find the nth root of a, here's your n value, here's your a value, and you guys have to know that they're asking us really to evaluate the nth root of a. So we have to be able to figure that out. So looking at the problem number 1 that we're given here, this is asking us to find the cube root, oops, I don't like how crooked the cube root of -216. -216. So I know from the box in box 1 that I'm going to have a negative number for my solution. This is really asking me what, let's do not equal signs, let's do an arrow. What number to the third power equals negative 216? What number to the negative sixth power is negative 216? So that might be an easy way of thinking about it. You can kind of guess and check. There is a way to type this into the calculator. So I'll go ahead and pull mine up here real quick. I'll just use my on-screen one here on my computer. To do your different roots, for some calculators, there is a shortcut button for it. For others, you might have to play around with stuff. I can help you guys out once once we're back together in person, or well, not in person, but once we're back together in class, I can help you guys figure it out for your specific calculator on how this will work. You can see on mine it's set up that I have a square root button here. So the square root of x, so I would click that and do like 9 if I wanted to do the square root of 9 and hit equals. Whoops, let's do 9 and then my square root. I have to type it in backwards here. So it gives me positive 3, which is super easy, but we're not dealing with a cube root or a square root right now. We're dealing with a cube root. So what I have to do is hit shift, and you can see on my calculator it pops up with 2 different options. I can do I have a third root button, which is this one that I have my cursor on right now, a cube root button. So in that case, I could do that for this. I would have to do 216, make it negative, and then do my cube root, and we get negative 6. Negative 6. Now, this functionality might be different on yours. Again, you might not have a cube root shortcut. You might just have this other one that I'm about to show you, which is this. This is a y. You can see I've got a y in my radical and my index, where that n usually is, and then an x value for my base, for my underneath the radical. Now I'm going to play around with this real quick to see, because every calculator might be different. You might have to type in your index first, so the 3 first, hit this button, and then negative 216, or it might be vice versa. I'm going to try both ways real quick and see which one works. So let's go ahead and clear everything. Let's see if we can do, all right, 216 negative, and let's try this, and let's do this. Okay, so that works for me. So at least on my built-in calculator on the computer, I have this as my option. So I have negative 216. I hit that special root button and then type in what root I want to find. So we'll use this again in a second for number 2 that we're about to do, because that's a little bit different, but we can see. Either way we get to it, whether you're a guess and check person or whether you're using that calculator, we should get that negative 6 is my solution, which you can check your work. If you use your calculator to kind of guess and check, you can then go ahead and multiply negative 6 together 3 times to make sure that it comes out to negative 216. Okay, so for number 2, we've got the nth root of a. Our n here is positive 4. Our a value is 81. So for this, we're asked to figure out what's the 4th root of 81, which is the same thing as what to the 4th power is 81. So again, you could guess or check if you want to here, or we could go ahead and pull out our calculator. We can start plugging in numbers if you want to do that form of guess and check. But I'm going to go ahead and use my calculator now that I know how to do that specifically to go directly to my answer. So on mine, again, 81 is what I'm trying to find the root of. I'll go ahead and click second. You can see again right where my cursor is at right now, my y root x button. And I'm going to go ahead and type in 4 for my answer. And I get positive 3. 3 is my solution, which makes sense. If you did 3 times 3, that gives you 9. Times 3 is 27. Times another 3 would be 81. So we get 3 is my solution. Now I have to be careful here because I have an even root. So I have to go and check on these rules, because now I took the even root of a positive number. So in this case, I do have my plus or minus symbol that needs to be added in there as well. Because I could do positive 3 to the fourth power to give me 81, but negative 3 in a parenthesis to the fourth power would also give me 81, because negative 3 times negative 3 is positive 9, 9 times negative 3 is negative 27, and then negative 27 times negative 3 would be back to a positive 81. So you have to be careful on those. Just make sure you check your stuff, check that table if you need to ensure that you've got the correct solution. But again, the only time where you have multiple solutions, you have to add that plus or minus symbol, is if you've got an even root for a positive number. That's the only time you have that plus or minus. Everything else should either be 0 for your answer, no solution when it's a square root or an even root of a negative number, or you've got a single solution of the other roots. Okay, so now I'm going to jump back over into box 1 real quick and talk about a different way that we can write this. Because for some of us, we might not have that shortcut on our calculator for being able to do a specific root. So I want to show you a way to do it using exponents. So if I'm dealing with a root, so let's just say I'm going to put another bullet point here. If I've got the nth root of a, my nth root of a can also be written in exponential form as a to the 1 over n power, which is very strange, but that's another way of writing it. So if I want to convert from a radical to an exponent of the same exact thing without going through and like rearranging the whole equation like I did there in blue, I can convert back and forth between radical form and exponent form by changing it into a fraction. If I'm just dealing with my a as my base, and I'm just dealing with n as my root, I can rewrite it as 1 over n instead. So again, if we wanted to convert this one here then blue, draw an arrow down here, the square root of 9 would also be 9 to the 1/2 power equals 3. That's an equivalent way of writing it just as an exponent. So the reason I bring that up is because what we're going to be dealing with now is other fractional exponents. So box 3 is all about rational exponents, rational just being ratios, which is fractions. So you'll hear me use both phrases, rational and fractional exponents. Just know that you guys should know they're the same thing. So for our rational exponents, we can have things that are more than just 1 over n. And actually, if you look back here, the reason that we have it as 1 over n, we don't usually write them, but we know anything that doesn't have an exponent written above it, there is an exponent of 1. Just like there's an imaginary coefficient of 1 that I could write here if I wanted to, or you could put this as an imaginary fraction over 1. All of those things are still totally allowed. But more specifically with our exponent of 1, that's where that 1 in 1 over n comes from. That rearranging of my radical term to my exponential term, the nth root of a to the first power can be rewritten as a to the 1 over n power. Which means that if I wanted to, I could rearrange things that are already fractional exponents going back and forth. For this top row here, we can see, depending on which direction you want to start, if we want to start down on the right side here and work our way this way, we can say, all right, well, if we have the nth root of some a to the m exponent, so m is our exponent on a, n is our root, we could, these two steps here that I want to highlight in blue, these two are just kind of different ways of rearranging it. Our m could be on the outside exponent, it could be on the base itself underneath my radical, but really these are just different ways of rearranging it. So notice some things that I'm highlighting. I'm just going to focus on the two end caps here. Notice my m that was the top of my fraction is the exponent, either on the a directly or outside of all of the a. And then my bottom of the fraction becomes my root, becomes my nth thing. So usually, again, we're dealing with the two ends of these equations. The same thing applies with our negative exponents. Like we saw yesterday in our exponent rules notes, anytime we deal with a negative exponent, we know that in order to kind of resolve that, or to get rid of my negative exponent, we have to make sure we flip it over, and then my exponent becomes positive, which is why this is basically the same set of equations, except that now, after I get rid of that negative number, it's just in my denominator as, of the fraction. But our same two rules. Top of my fraction becomes the exponent on the whole thing. My denominator becomes the root of the whole thing. So the last thing that we're doing today for box 4 is just working on converting back and forth and evaluating with our fractions as exponents, or rational exponents. So starting with number 3, we've got 16 to the 3 over 2 power. We would rearrange that. 16 is still going to be my base. We've got 3 as the top of my fraction. We could, this is the beauty of things, you've got your choice. You could either say 16 to the 3rd power, all underneath the 2nd root. So that's again how it gets rearranged. Or you could say the square root of 16, all being raised to the 3rd power. Either of those two things, exactly the same. Well, they're not exactly the same. They will get you the same answer. It's just which one is easier to work with. I prefer this right method. When I'm trying to simplify something, I would rather take my square root first or take my root first, because usually I can get that into a smaller number, and then I can go ahead and raise that 3rd power from there. So I'm going to go ahead and do that. I'm going to do that right one. So now I know the square root of 16, well, that's just 4, right? Actually, we know that it's actually plus or minus 4 being raised to the 3rd power, which that ends up giving me plus or minus 64. If you wanted to, if you didn't want to do it kind of this old-fashioned way and do it in your head, for those who can do that, I encourage you to do that because it's faster. But for those either who don't trust themselves or those who want to just double-check their answers or prefer using the calculator, there is a way to do this in your calculator as well without even having to rewrite it. If you wanted to go directly from what you were given, 16 to the 3 over 2 power, you can do that directly in your calculator by typing this in and hitting equals. 16 to the parenthesis 3 divided by 2, close my parenthesis, power, that'll give you plus or minus 64. Actually, in this case, I think it gives you just positive 64, so you just have to take a look and remember and realize that whatever the bottom of your fraction is, that's your n, that's your root. So if you're dealing with an even exponent or an even root, you have to make sure that if your base was positive, that you had that plus or minus there at the end. That's still, those rules still apply when I'm dealing with fractional exponents, because again, those denominators are my roots. Those are my n values. So if I wanted to take a look at something like number 4, we've got 32 to the negative 3/5 power. So again, we could take the cheap way out if we wanted to and just say, all right, well, I'm just going to do 32 to the negative 3 divided by 5 power to get my answer. Your calculator will spit out 0.125. If we do it the old-fashioned way, I got to flip it first. So I'm going to flip it the negative, tell the negative exponent tells me it's going to be a fraction. And now if I go ahead and rearrange right away, this is going to be the 5th root of 32 cubed. Again, my denominator becomes my root. My numerator of the fractional exponent becomes the power on my root. So from here, I know that's going to be a 1 over. I have to figure out what the 5th root of 32 is, so you probably have to use a calculator for this. I'm a smart guy and also have the answers, so I know that that's 2. Because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Beautiful. 2 to the 5th power. So 2 cubed is 8, so 1/8, which is the fraction version of 0.125. Either way you slice it, you get the same answer. I'm fine with either. I prefer fractions because it tells me you know how to do it, not just necessarily how to type it in the calculator. But you guys also know that even if you used your calculator, if you're good enough at using your calculator, if you got to 0.125, you can also just type in your conversion of fraction to decimal button to get 1/8 as well. So really, as long as you can do what you need to do, that's all I really care about. That's all I got for today. Homework is page 241, 6 through 20, just the evens. As always, if you guys have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a great day.